Hi, welcome all to the webinar that Nozomi Networks together with Fortinet is presenting, hosted by Exclusive Networks.
Okay, hello everyone, good to have you. Today we want to present to you a couple of features that we can share between Nozomi and Fortinet when we integrate. We have here today myself, I'm Steven de Mot, BDM OT Security at Fortinet, and sitting right next to me,
Jeffrey Noya from Nozomi Networks, the technical engineer there for the region Benelux.
All right, so the agenda for today is quite concise, I would say. First, we'll briefly introduce you to the IEC 62443 framework. Then we will move on to some of the highlights in the technical capabilities of Nozomi on the one hand, Fortinet on the other hand, and we'll present you a combined reference architecture. And after this, we have a small demo part, and we will show you the value of basically combining the two products and making 1 + 1 = 3. And then at the end, we have a Q&A session, so you can ask your questions in the questions part of the webinar, and we will answer them at the end of the webinar. Okay, so without further ado, let's talk very briefly about IEC 62443. It's the most important framework being used to secure OT environments. It really talks about the classic 3 pieces: people, processes, and technologies. So it makes it clear what people's responsibilities are. It helps you create processes as a company. The end goal is building a cybersecurity management system. It can help you assessing your risk. And of course, it will also explain the technical measures that you should make to secure your network. Now, some of the foundational concepts used in the framework are called foundational requirements. Basically, these are the conceptual parts, or let's say verticals of security that you need to implement in order to secure your network. If you go deeper down, you drill into the actual system requirements, and then on top of that, you can add requirement enhancements that you can use to reach a certain security level. So that's the concept of the framework in a nutshell. It's a couple of 100 pages long, so I summarized it very quickly. And on the right here of this slide, you can see that both Nozomi and Fortinet have made a convenient mapping for you to say which products or which part of their products you can use to achieve these system requirements. So we're not going to go over the entire framework, as I said. I think we want to highlight a couple of things here, and the first one I'll let you explain, Jeffrey.
Yeah, sure. So one of the requirements in the 62443 standard is that you have a system under consideration, and the system under consideration is that you have to evaluate all the assets in that system under consideration to see how that is communicating, which risks are involved, but also what could you do, what security precautions could you take to better enhance the security there. And what's often overlooked is that a system consideration is not only on-premise, everything that has related to the process, so even cloud connected or clouds itself that you do some process automation or help with the automation process are a system under consideration. So keep in mind, industrial IoT cloud-based solutions are really something to consider as well. So, and what is important about if you're going to look at systems is that you're going to look at the assets that are there. So the asset owners often don't have the full visibility of the assets they have in the landscape. So it's important that the tooling can help without being very chatty on the network, so without being intrusive. So that way we as Nozomi have the Guardian sensor, and the Guardian sensor is a sensor that listens on a span port, a TAP, or RSpan port, or ERSpan port, and just by the traffic that's passing the network, we can start identifying assets and start profiling those assets. The additional features that we have is that if we haven't seen something passively, it hasn't traversed the network, or it just doesn't talk at all, then we have the possibilities to enrich the passively detected assets with smart polling. That are queries in the language of the device. If you talk about Siemens, that would be a 7, a read query to fill in the missing information and be as light as possible on the assets. And complementary to the Guardian sensor that we have, we also have a host-based sensor, which you can use to get rapid overview and insights of a Windows asset, for example, but also what's happening on that Windows assets. And we are a detection tool, so we detect things on the asset, we report on those things, so we can see scripts execution, we can detect anomalies there with behavior, for example, a user that's logging in at strange times, but also if a USB device is plugged in, and for example, in between is a keylogger, we can detect the deviations in the voltages and say, hey, we see that something strange is going on. So again, only detecting, not blocking. And the blocking part can be fulfilled, for example, by our colleagues with FortiEDR. So the other thing next to the asset visibility is also the security and operational capabilities. What's important about that is that you want to combat the issues on your network. So we have the known threat detection, that's signature based. We can do deep packet inspection of all the OT protocols so we can understand what's happening. And the signature base is all layer 2 traffic. So we're not relying that it has to traverse a higher level on the network. So layer 2 traffic is enough. And next to that is that we can do anomaly-based detection. So where we see deviation from the baseline, with deep knowledge of the OT protocols, where we can alert on, for example, function codes that haven't been seen, process variables that have been changed, and so forth. So this really helps you with getting good insights, and not only security, but also operational. A bit further with the operational insight is also in the 62443, they ask you to get control over your network and visualize all the data flowing over the network. We can visualize who's talking to who on the network, so you can see how the communication lines within a zone or segment are, but also between the zones. So for example, to detect if there are connections to a zone that shouldn't be there, or for example to the internet, which might be also not allowed there.
And okay, after the visibility part that Nozomi covers very well, that's basically where Fortinet can help. So I won't fall into the trap of explaining every product that Fortinet offers, or will be here for longer than the time that we have provisioned for this webinar. But I wanted to highlight a couple of the main things that you should remember. So first of all, we talk about our security fabric at Fortinet. We have made it OT aware, meaning we use the same products that that you know from the IT side of Fortinet, but we also basically we made them OT aware by adding threat intelligence and different implementation processes for our products. So if we talk about the networking part, that's really where the connectivity happens. Right? It's from deep down in the network connecting onto the SD-WAN part and the 5G connectivity. That's what we do with our typical FortiGate and our Forti switches and our Forti APs. We can do, of course, segmentation, which we will cover later in the webinar, where we can showcase our integration. The second part is the zero trust access, another very important part of what we do here at Fortinet. And I wanted to highlight there, on top of the classic things like VPN and token technology, the FortiPAM product, which means privileged access management. It's a very, or secure remote access. It's a very much talked about use case these days in OT environments, because you have a lot of third parties connecting into your network. And a lot of customers fail to have the right control over those connections. So what we do with our FortiPAM product is we store the credentials in a central location. We give access to the people that should have access. You can add approval workflows if you want. And we also do the compliance part of these connections, meaning we record them and you can access what has happened through the logging system. And then moving on to the security operations part, another very important vertical if you want to cover end-to-end security, of course. our FortiSIEM product is really also optimized for OT environments. That's where you can bring all the event information together and you can correlate it. We also implement the MITRE ATT&CK for ICS framework there, so you can really map it to OT-specific use cases inside the SIEM. And of course, if you have a lot of events, you'll also need some automation, and that's what we can do with our FortiSOAR product, automation and orchestration. Yeah, that's where you generate your playbooks. We have some default playbooks in there to respond to certain types of events, and of course, you can create your own. And then on to the last product I want to cover here quickly, which we will explain a bit later as well. It's FortiDeceptor. It's basically honeypot 2.0 technology. It's a distributed way of deploying honeypots across your OT network that can mimic OT devices, so you can lure attackers towards them and then report on the activity that happens there. And all of what I said is being made possible, of course, by the threat intel from our FortiGuard intelligence agency, which creates our signatures for the IPS part, but of course also for layer 7 traffic inspection. So as a result of this, we see a reference architecture, which basically shows a combined architecture for Nozomi and Fortinet. So
yeah, what you see at this architecture is how we can cooperate with each other. So the Guardian sensors are really ingesting the data, all the data of the network, and really process and give that visibility to the whole network, see the alerting, see the deviations in the network, where we can then feed, for example, the FortiGate with our alerts to do some blocking, for example, or we can feed other Forti solutions to make sure that we can cooperate and interpret each other. And what Stephen was referring was, for example, the SIEM. We have worked together on making this better. So we have parsers. So the FortiSIEM really understands what we are sending to them. So I think that's one really important thing to highlight.
And as you can see, the FortiGates are always positioned between the different levels of the Purdue model here. You can put switches in the lower levels as well, EDR on the workstations in the supervisory control, and then the FortiPAN in your DMZ zone. So that's, I would say, a high-level overview of an architecture that you could reach if you want to combine our strengths. And segmentation?
Yeah, segmentation. What's important about the tool, the Guardian, Nozomi Guardian, is that we gather the information of the network. So we see everything that's being sent. So we also see communications between two assets, for example, even if they are on the same VLAN or segment of the network. And usually what you see is that customers have challenges with looking how to segment because they don't know who's communicating with who. And actually our tool can give you those insights, gives you the insights about protocols, about bandwidth usage, about ports that are being used. And actually our output is really good input to feed a solution like the FortiGate to better implement segmenting there.
Yeah. That's fantastic, Jeffrey. If you can use this as a baseline for your segmentation project, you're no longer in the dark. You don't have to start investigating with the people what should be communicating with what is actually communicating in my current network setup. You really have something to start from, and I wish this existed 10 years ago when I was implementing these kind of projects already. So it's yeah, very nice to see and very helpful collaboration.
One thing to add there still is that, for example, we do deep packet inspection of all the OT protocols. So we also see, for example, in Modbus, which function codes or read or write commands are being used. And if you see that that's not the case, that you don't want that, you want to limit that, then actually we can show you what's happening. And then the application control of the FortiGate firewall can control those streams, which really helps it.
Yeah, thanks. So moving on to the demo, we want to show you here what it looks like in practice.
Yes, so what you see here is the Nozomi Networks Guardian, where you see that we have assets. We detected assets on the network. And what's going on here, this is an engineering workstation, which is using, in this case, a Modbus command to retrieve, for example, the firmware information. But this could also be just a function code that's being sent. What you see in our Guardian is that we've detected what kind of device it is. It talks Modbus and also the peer that it's talking to. So both the controller and the engineering workstation are fully in scope, and we fully learn that those two are communicating normally with each other. So that's important. What's even more important is that you want to detect abnormal behavior. So what we can do is change from learning to protecting mode, which means we close the baseline. And then from that point on, any deviation that's being triggered, of being alerted on, we can work with the FortiGate together to block those. And the use case of an engineering workstation that is being compromised is one that's often being looked at. And you want to maintain the regular connection. So the Modbus connection, you want to keep using that, but you want to kill those deviating the destinations. So what you see here is a FortiGate firewall with just a generic rule to allow communications. And now I'm going to start here an Nmap scan for the segment of OT assets. And that's a complete scan of the network. And you don't want to have that in OT, and you want to make sure that mitigating actions can be taken here. So we see all of those things happening. The Guardian starts flooding with alerts because these are all deviation scans to IP 123, port ABC, and so forth. And due to our integration with the Fortinet firewall, we can very precisely and accurately kill those data streams that are not normal. What you see here is that the source of the engineering workstation and the destination of the address that they're going to block with a specific port that's being probed. And you will see when we refresh the firewall that those rules have been injected. And that way you have very granular control of blocking data streams and not the normal data streams. And if we wait a bit more, then you will see more scans have been happening over time. And there's also more firewalls have been injected. And I think it's important to highlight that we very granular send firewall rules to make sure that we don't kill valid streams. So I think that's really important to emphasize. And what you'll see now when we refresh, the FortiGate has a lot of rules more because of all the additional scans that happened. So I think this shows how fast we can integrate and how fast we can act in when we detect something. This could be deviating behavior, but also other things that are happening on the network. And to emphasize that normal traffic still works, you see that I do a Modbus command here, and that's still reachable, just as before. So I think that's important to highlight. Very granular control of blocking that can be on a VLAN level, or that could be at a whole firewall level.
Yeah, you covered a lot of interesting use cases there, right, Jeffrey? So the concept of real-time integration into our FortiGate, creating the rules automatically, and also keeping the operational traffic alive. That's really critical in what you've shown us. So this is basically a visual representation of what Jeffrey just explained. On the left, you see that we have the capabilities because we both understand OT protocols. We both are able to go into that level of depth. Right? So we can block things that shouldn't be happening while still allowing things that should happen inside the same protocol. That's really the power that we just wanted to show you here. And on the right, a visual that's talking about our virtual patching technology. So basically, it's added on top of this. Again, we look inside the protocol for anomalies in the traffic, for exploits that are being sent across the network. And we all know that in OT, you can't just go patching the devices at any point in time. You'll have to wait until a certain shutdown, maybe at the end of the year. You have 1 week to patch your whole environment. We can actually virtually patch things in between on a network.
Yeah, and because we talk about 62443, it's also important to emphasize that frameworks and standards are important because those give us a big help in structurizing and improving our networks. And Nozomi Networks has 62443 reporting for 2-1, 3-3. So you can make sure that when we detect data that we can format it in a proper report, which is human readable by the people who understand the standards. So the reports that are coming out are really highlighting which security requirements have been detected to be in place. And I think that will help customers a lot.
And on top of that, we have been adding in the latest version of our FortiOS, we have been adding a Purdue level mapping of the assets in your environment. So this applies to FortiGate, but also to FortiAnalyzer and to FortiSeam. You can visualize your assets there in a Purdue model-based visualization. Yeah, we have a second demo for you here. So let me go ahead and start it. Yeah.
Yeah. What's important about this is that we have the Nozomi Guardian and the FortiDeceptor combined here. So this gives you unique insights in a network level view, but also an asset level view, because the decoys act as a real device and see when somebody tries to reach them. So this gives you deeper insights in what's going on. So in this case, again, I have the engineering workstation, which is actually accessing a device on the network, for example, Schneider PLC, but we're also trying to scan the network again. So a similar action like before, but it's interesting to see how these solutions can help each other. So what's important here is when we start the scan, alerts are popping up in the Guardian. So the Guardian will start adding data and start adding alerts there where needed. And that's good from a network level perspective, because we really show each trace of the attacker on the network side. But what's also important to know is how these two tools can complement each other, because on a Deceptor view, you can see this is happening on my assets. This URLs, for example, being reached, or these actions are being done on the endpoint. And as you see, the scan is progressing, it takes a bit more time, and over time, more alerts will pop in. So you will see the Nmap scan has 255 addresses. You see here now the FortiDeceptor interface, where the alert is mapped in a similar timestamp as on the Guardian. But we see, hey, anomalous communication, this is happening. And the Deceptor says, hey, this is happening from an asset perspective, and like us, also maps it to the MITRE ATT&CK framework for ICS. And this way you get deeper insights from both angles, and we really implement the defense in depth strategy here, because it really complements each other.
So what you are seeing is anomalous network traffic, and what we are seeing is a honeypot that shouldn't be touched, but is being touched by the scan. So that's indeed, I think that showcases that both products combined can give you a lot of extra information. So what is this honeypot technology actually? So FortiDeceptor, it's you see the device here in the middle. I don't know if you can see my mouse, probably not. Yes, I think you can. So the FortiDeceptor device is in the middle here. It could be a physical device, a virtual device. On top of that, you have virtual machines running, and those are the ones that mimic real devices in your network. So it could be mimicking a PLC, could be mimicking an HMI. You see below here the long list of OT decoys we have. We of course also have IT decoys, so you can also mimic Windows servers, for example. So what happens if if an attacker touches one of these decoys, which it shouldn't be? We'll immediately know it's a very high value alert, because nothing should ever touch this. So what we do then is we send an alert log back to the FortiGate. We can log it in FortiAnalyzer and FortiSeam, and at this point we can even respond to it. We can send threat response automated integrations, basically with Fortinet's own products, like FortiGate for quarantining the IPs, EDR or NAC to isolate the devices, either from a network level or from a host-based level. You can trigger a playbook. So you can really do a lot of things, not just the alerting, but also the active response. Of course, optional. If you don't want automated responses to your events, we understand it's not always what you want in an IT environment, but it's definitely possible. So it gives you really an early warning system if an attacker is looking around in your environment, and you can really also deploy this in a non-intrusive way. You don't need to reconfigure your network. You can just deploy the device centrally, and the VMs basically are connected to a virtual network that is in the same VLAN as the VLAN you want to protect using the technology. So time goes fast. I think we're at the end of our webinar already. We've showed you, we've highlighted a couple of the integrations that we have, but yeah, there's a couple more. Maybe Jeffrey, you can quickly go over what we do together.
Yeah, what I think is we emphasize mainly the FortiGate integration, and we named some of the SIEM integration, but know that we can integrate as Nozomi with a lot of Forti products. So so with the Nozomi Guardian, the FortiGate we demonstrated, we actually work with any FortiOS version from 6.4 till the latest 7.4 X series, but also FortiSOAR for an automation layer. And with FortiSOAR, actually anything can be integrated as a response action. FortiNAC, where we can feed our data set to FortiNAC, which then can be used to better profile assets that need to go to a certain VLAN, for example. At FortiSwitch, we can monitor the health activity for the switch, we can monitor firmware versions, but we also, due to the integration, can also say, hey, the FortiGate block action that we have could also be extended to the switch level, so that even within the same segment, for example, data streams could be killed. And SIEM is the good way to have one view of looking at all those data sets. So the gate sense data, so the NAC sense data, the Guardian sense data, but also the Deceptor sense data. And from all those different angles, those are correlated in FortiSIEM. And because we work with Fortinet together on building the parsers, you get deep insights in those OT alerts that are there. And combined with the Deceptor insights, it's really a really good data set to work with.
Indeed. Okay. Thank you, Jeffrey. Thank you, Exclusive Networks, for hosting us. I wonder, do we have any questions? Looking at our host here, did we receive any questions during the presentation? Okay. We'll give it a couple more seconds if somebody thinks of something.
Yeah, and if, for example, any of the integration questions or things pop up later, you feel free to reach out to us also, because we will leave the contact details also in the slides, which are going to be shared by Exclusive, I guess. So you know how to reach us and to see if there might be some use cases for integrations, or to see how the solutions can work together and help each other.
Very good point indeed, Jeffrey. We needed to mention this was a small part of the integrations that we have. There are different webinars that cover existing integrations. For example, recently there was a webinar about the FortiSIEM integration specifically that was hosted by my colleagues from EMEA. So definitely there's a lot more information available, and don't hesitate to contact us on the details that we are sharing here. And yeah, always available.
Good. Someone has one question. Yes. Right, second question.
We have a question.
So Nozomi Guardian, I see a question about what do you need to run the Nozomi Guardian? Is it an appliance? What is connected to it? Well, the Nozomi Guardian can be flexible. We can be a physical appliance, either ruggedized, non-ruggedized. It can be virtualized, so you can run it on any hypervisor, or you can do it containerized, so Docker compatible. It's up to you what's most flexible for you to fit it. For us, it all works, so that's nice. Keep in mind we need span data, R span data, or ER span data to work with these data flows.
Rizwan, I think you've got a question. You can ask it. I've unmuted you.
Yes, thank you. My question is about the Nozomi integration with FortiNAC. Does it help FortiNAC with device profiling and also with the access policies on the switch level?
What we actually do, we are a data source for FortiNAC. So what we do, because we have very accurate asset information seen on the network, then the FortiNAC uses actually us like an MDM-like tool where it can import our data sets, and based on that, you can assign FortiNAC policies on it, which can then lead to a decision X, Y, Z. So we are a data set for the FortiNAC solution, and in which we have already done a lot of asset profiling, where the profiling otherwise take maybe a bit longer on the FortiNAC angle, because if we already have it, why wouldn't you use it, for example?
And one more question. So the Nozomi network device uses an API to make the firewall policies in the FortiGate against the baseline that has been created by the Nozomi device. Does it also delete or remove the policies if not used or compared against the baseline and it has changed?
So we intentionally do not remove it because, for example, if an asset is compromised which generates data streams and it stops sending data, it could still be compromised. So there needs to be a manual triage on the endpoint, for example, or on the infected system or the system that's causing anything, to be sure that nothing is happening anymore. So we intentionally do not remove it. We have a granularity which you could do, is not enforcing firewall rules, but that you say, I want to do kill sessions, and when the data streams do not pop anymore, then we stop the kill sessions commands.
Okay, and so let's say you have solved the breach, you would have to manually remove the policies that the Nozomi device has created, or could you run a playbook?
Yeah, if you use the firewall blocking features like with rule injection, yes, as I said, because we don't want to do it, remove it, because we do not know if it has been mitigated, because it can just be silent. The kill sessions is a way of working around it. The other way is, for example, usually a customer also has FortiManager, and what you then see is that we have injected rules, and then the FortiManager says, hey, there's a policy pack conflict, and then you can say, hey, resync my FortiGate when it's mitigated. So the FortiManager sends the default policy pack it had to automatically remove the new rules that were there.
Yeah. Okay, perfect. Understand.
Okay, great.
Thank you. Well, if we don't have any more questions, I believe we can conclude here. Right? The recording will be shared to everyone that attended, and please feel free to redistribute it. If you want to add something, Jeffrey?
No, yeah, I think it's good questions that were asked, and yeah, as I said, please feel free to reach out if you have any other inquiries, or maybe you want to set up a Teams meeting to discuss some possible integrations or possible opportunities together. That's always nice.
Okay, thank you.
Thank you for your time.